In this video, we will discuss acceleration. Acceleration basically means some sort of change in velocity. There are two different ways in which acceleration can happen. A quick reminder here that velocity is a vector, so it has magnitude and direction. Since acceleration is change in velocity, a change in the magnitude of the velocity results in acceleration. A more common name for the magnitude of the velocity is speed, so when an object changes its speed, it's accelerating. Two examples are: a car traveling on a straight road speeds up from 20 km per hour to 30 km per hour, or a boat slows down from a speed of 10 meters per second to a speed of 5 meters per second. This is sometimes called deceleration. A second way in which acceleration can happen is a change in the direction of the velocity. Here are two examples: a biker turning left at an intersection, or a skier going over a small hill. Even if we assume that the speed of the biker and the skier does not change, they are both accelerating because the direction of their velocity is changing. Since acceleration is a change in velocity and velocity is a vector, acceleration is also a vector. In most cases, when you have to calculate the value of acceleration, acceleration happens because of a change in speed. If we know the change in speed and the change in time, we can use the following formula to calculate the acceleration. Let's see an example. Acceleration, a, is equal to change in speed, so delta v, over change in time, so delta t. A quick reminder that the triangle that you see in front of v and t is the Greek letter delta, and in physics it means change. The speed of the car increases from 10 to 20 meters per second, so change in speed is 10 meters per second. This is divided by change in time, which is 5 seconds. Therefore, the acceleration is equal to 2 meters per second squared. Here we get meters per second squared as the unit of acceleration, because we are dividing speed, which is in meters per second, by time, which is in seconds. So the SI unit combination of acceleration is meters per second squared. A final key point to discuss before we wrap up this video is the difference between average acceleration and instantaneous acceleration. What we calculated in our example is the average acceleration of the car during the 5 seconds. Most likely, the acceleration of the car during this time was not a constant 2 meters per second squared. Instead, this acceleration value was most likely changing from moment to moment, depending on how fast the car was changing its speed. So one way to explain instantaneous acceleration is that it is the acceleration at a given moment. The concept here is very similar to that of instantaneous speed or instantaneous velocity. This wraps up our discussion of acceleration.